but your faces won't be on there. Okay, guys, welcome back. We're doing 11.7 now. But before we start, any questions about the homework or anything previously?
No.
No? Okay, good. So we are doing 11.7, which is really just it's kind of just review. Just putting everything together in one. But here I have the formulas gathered together. So this one is from the first section, yeah. Simple interest formula, I is equal to PRT. P is the principal, R is the rate, T is time in years. And that's gonna always be true. R is always gonna be the rate as a decimal. T is always time in years, yeah. Here A is always representing a future value. So future value, they're starting P plus times 1 plus RT. These are for simple interest. So look out for simple interest or look out for when it says there's no compounding or does not mention compounding. The next type of formula, these two are connected to each other. It's 2A and 2B because these are actually the same formula, just solved for different letters, right? If you see compound interest and you see that it's just a single time principal, you just put down money one time or you borrow money one time, that's when you use compound interest formula. So A is equal to P times 1 plus R over N to the NT. And then if you want to know, instead of the future value, you want to know how much you should put down to end up with some future value, then use the present value instead. Okay, the next one we learned was the annuity formula. This one is for, like if you're saving for retirement, right? And you know the monthly payment M, you know the rate R, you know the period T, and you know the number of times compounded it or put down money in a year. And then you use this one. This will tell you how much money you end up with. Yeah. And then periodic payment for annuity, this is the other way around. So 3A and 3B are connected again. If you know how much you want to end up with target goal, then this tells you how much you should put down at each period. Okay, and then we looked at amortization. So how to pay back a loan. There's two formulas for that. First one tells you if you know the payment amount that you can afford, how big of a loan that you can take. And again, R is rate as a decimal, N is the number of compounds in a year or number of payments in a year in this case, and T is number of years. And then 4B was just the related value rate. If you just solve for M instead, this will tell you how much your monthly payment should be if you know how much the loan is. Okay, so this is just a recap of everything we've done so far. Then also we had the APR estimation formula. So that's the annual percentage rate. Capital N was the total number of payments, and R is the rate as usual. Okay, you guys remember all this stuff? Any questions about any of these?
No.
Okay, let's continue then. So we're just practicing basically. The big thing today is just to practice figuring out which formula is going to apply for which situation. So we're just going to practice reading a question and then trying to figure out what formula to use and then cranking the thing out. So let's start with number 1. Just find the value of a $1,000 certificate in 5.5 years at 10% interest rate, compounded semi-annually. So which one do you guys think that is?
Just look it up. Look it up.
Was that Brett?
Compound interest, future value.
Yeah, right. So a few keywords, right? It says compound, and you're only putting money one time, $1,000, and you want to know how much you're gonna end up with. So yes, compound interest, future value. So this is the guy we want. Yeah. Let me just type it out. That's what we're using. And we're looking at, okay, let's just write down our variables as usual. So P is 1,000. T is the next thing given to us, 5.5, so 5.5. Rate is 10%, so 0.1. And semi-annually means N is going to be twice in a year. So that's all I plug in here. just gonna plug it right here like this. 1,000, 0.1, 2 times exponent in parentheses, 2 times 5.
Okay, with respect.
And I get 1,710, 34 to the nearest cent. Yeah, that matches the bottom value here. Yeah. So we're just doing the exact questions that are on the paper this time. So I have I sent that to you guys, also posted it to Lalima. All right, any questions with number 1? Is that good? Are we ready to go into number 2? Just plug it in and get the same thing?
Yes.
Okay, excellent. Okay, number 2 then. What is the annual deposit? What annual deposit is necessary to have $10,000 in 10 years? The interest rate is 8% compounded annually. Okay, so which situation do you think this is?
Future value?
Let's
Compound
see.
interest?
It says what annual deposit. So it's not going to be a future value because it's telling you the future value right here, right? You want to end up with 10,000.
Uh-huh.
So we know the future value, in other words.
Devil dog call. It's actually.
So we know the future value, and we also know we're making annual deposits, right? So what you guys think?
The number, is it 3A?
So 3A is also future value formula, right? So it's not that one because I know the future value. So it's going to be, it's asking for the annual deposit, right? I know the future value. So I don't want to solve for A, I want to solve for the annual deposit, which is the periodic payment. So you want to take, your 3A is actually close. It isn't an annuity question, but you want the periodic payment amount.
What's going on here?
Sorry, I'm going to, okay, so we're using the, so Brad, if you have a question, you can unmute yourself and then ask a question. Yeah, so we're using the periodic payment for annuity, this one. Yeah, because we know what the future value is, and we're trying to figure out what is the periodic payment we should make. So we're using M is equal to A times R over N divided by 1 plus R over N. And then like usual, let's just try to look at what our variables are in this case. So it says we want to end up with 10,000 years, $10,000 in 10 years. So that means our future value we know is 10,000. The time is 10 years time. And interest rate is 8%. So 8%, 0.08. And it says what annual deposit. So annual means N is equal to 1. And those are all the letters, right? Just gonna fill them in. M is the thing I don't know. Let's see if you guys can plug that in and get what you, see if your number agrees with mine. So all I'm doing is just replacing the variables with their actual values. Can I get 690 and 29.48. So near 690 and 29. And that agrees with what I have down the bottom. So looks good. Okay, is that okay with you guys?
Yes.
Okay, sweet. Number 3 then. What is the monthly payment for a home costing $325,000 with 20% down, financed for 30 years at 4%? Okay, so we just did questions like this last section, right? This is a mortgage, so you have a big loan, and you want to know what the monthly payment is. So that would be, which one?
The amortization one?
Yeah, exactly. Right. Number 4B, yeah, we're looking at how to find the monthly payment. So it's going to be M is equal to P times R over N to the 1 minus 1 plus R over N negative NT. Okay, so let's look at what our variables are now, what the numbers actually are. Just so remember, there's an extra step because there's a 20% down payment first. So we want to start by taking that 325,000 multiplying by 0.20. That's the down payment. So you subtract that from the original. So 325,000 minus 65,000 gives you 260,000. Right, so let's make a note of our variables. P is 260,000. Let's see. Finance for 30 years, so T is 30 years. 4%, so R is 0.04. And it doesn't mean, oh, it says monthly, so N is equal to 12. So I just fill in those things. Zero 0.08, 12. There you go, 1907 and 79 cents to the nearest cent. Oh wait, see, I had something different, so I must have made a mistake somewhere. Or did I type something wrong? Oh, I see, I wrote 8%. This is supposed to be 4. I was thinking I was looking at number 2. There we go. Yeah, so we said R is 0.04, right? And so let's check. Yeah, now that matches up. 12.41 and 28 cents. Did you guys get that? Still typing? Okay, let me know when you guys catch up, and we'll move to the next one.
Okay, I'm finished.
I got it.
Okay, sweet. All right, let's look at number 4 then. Karen deposits $2,400 each year for 25 years into her account, earning 7% compounded annually. How much will she have at the end of 25 years? All right, which one is that? Okay, well, we know right away it's asking how much she's going to end up with, right? How much she's going to have at the end. So we know it's going to ask for one of the future value formulas. Let's see, future value, we have this one, we got this one, and we got this one. We got 3 of them. So how do you know which one it is? Which one do you guys think?
Is it the compound interest future value?
Okay, that's a good guess because there is compound interest, but it's not quite because she deposits each year.
Oh,
So yeah, so there's two things to look
am I
out
right?
for. No, that's good. That's a good guess. Actually, so there's two things to look out for. When you see compounded, you know it's going to be either the compound one or the annuity also has compounding in it. It's
Mhm.
kind of hidden.
Oh.
Yeah. So what the next thing to distinguish between, once you see compounding and you're trying to figure out what you're going to end up with, the next thing is how many payments do you make. If it's one time, it's the compound interest. And if it's multiple times, then it's this guy. And if you look at our
Okay.
question, yeah.
Oh, okay.
So because she deposits each year, then we want the other one. So we're using 3A. It's 3A. Brackets don't work for you. This guy. Okay, so let's look at our variables again. M is equal to 2400. 25 years is T. R is 0.07. And N is 1 because it says each year's deposits and compoundings annually. Those are matching up with each other. That's all. Those are all the variables actually. So let's just figure it out now. A is what we're trying to figure out.
Mm.
7. 1. Okay, so I end up with
This.
151,797 and 69 cents. Yep, that looks right. Matches what I had previously. So there we go.
Mm.
Okay, let me know when you guys are ready to move on.
Okay, I got it.
Okay, yay. All right, number 5 then. What is the necessary amount of money to deposit it once into an account paying 8% compounded monthly in order to have $100,000 in 30 years? Okay, so what is the necessary amount to be deposited? That means I don't want the future value this time, right? I already know the future value. The future value is 100,000. This is my goal. This is my A.
Mm-hmm.
So I want one of the formulas that tells me what I should start with. So it looks to me, and it's compound interest. So it's not going to be simple. It's going to be either this one, number 2B, or it's going to be 3B. So I want to know what to put in, right? But the thing that distinguishes it is it says one time. I'm only depositing once. So multiple deposits is 3s, right? Single deposits are the 2s. So I'm looking for 2B. This is the one. Compound interest present value. So 2B is the guy. P is equal to A over 1 plus R over N. Now let's just fill in our values. Okay, so I want to end up this time with A equal to 100,000. That's that. Let's see, what else it tells me? Necessary amount, deposit once. 8% compound annual, R is equal to 0.08. Compound monthly. So that means N is equal to 12. And in 30 years, so T is equal to 30. There we go. It's just, oh, P is the thing I want to know, right? So P is just fill in our values.
Present value.
Looks like I need to put in $9,144. So if I put in $9,000, then I'll end up with the value that I want. $9,144.34. Okay, let me know when you guys are there, and then we'll go to the next one.
Okay, I'm done.
Okay, let's move on then. Number 6 now. Okay, here we go. Number 6. The following problem is based on a 30-year fixed rate home loan of $165,000 with an interest rate of 4.75%. What is the total amount of interest paid? Okay, this is a little bit of a different question, but not really. So it's a home loan, right? Meaning we're gonna do, actually, well, I'm not gonna say anything actually. Which formula do you guys think would apply here? I'm trying to find the total interest paid. 30-year fixed rate home loan. In other words, a mortgage. There's gonna be a little extra work we have to do. It's not gonna give us the answer from the formula immediately.
4B.
4B is correct. Yes, Taryn, good job. So we want the amortization formula because we gotta figure out what the monthly payment is before we figure out the total amount paid, right? So that's correct. It's for home loan. Remember, mortgages are always pretty much gonna be 4A or 4B. Okay, so let's copy that formula down. I think we did one before like this already, but it's good. M is equal to P times R over N divided by 1 minus 1 plus R over N, negative NT. Let's just copy down the things that we know. Look at number 6. Let's see. P is the amount of the loan, 165,000. There's no down payment in this case. It's already taken care of. We're just looking at the, what do you call, the mortgage itself. Let's see, 30 years, so T is equal to 30. This is in order of appearance. Interest rate is R is equal to 0.0475. And N is going to be 12 for monthly payments. And those are all the letters that I need. This is the thing I'm trying to figure out. 165,000, 0.0475 divided by 12. And same here. And it's negative 12. T is 13. Okay, so the monthly payment is 860.71.718. Let's do that to the nearest cent. So 860.72. How many times did I pay that? I paid that for 12 times a year for 30 years. So you, in total, you pay $309,859.20. And then let's subtract the loan amount. So loan amount was 165,000. And I get 144,859.2. Let's see if that matches, because I might have rounded. Oh yeah, that's right. Okay, so actually I wrote down all three steps here in the answer. Monthly payment was 860.72. That's what we got here and here. Total paid was 309,859.20. That's this value. And the total interest is the difference from the total amount I paid minus the loan itself. This is how much is paid in interest. So almost paid the entire loan amount itself in interest. So you almost paid double. It's for 4.75%. Currently though, the markets I think we were looking at before is like 3% or 3.something% is the current average mortgage rates. Okay guys, let me know when you're ready to do number 7.
Okay, I'm ready.
Okay, sweet. Let's go. So we're on number 7 now. Calculate the amount of simple interest earned if $1,000 is deposited at 8.5% for 7 years. So let's do that one first. What form do you guys think? What number?
1A.
1A. Yeah, 1A. That's pretty clear because it says simple interest, right? And it's asking for the interest. So, yep. I is equal to PRT. It's an easy one. Okay, let's just look at what we know. We were trying to figure out what I is. We know P is $1,000. We know the rate is 8.5, so 0.085, and T is 7 years. 1,000, 0.085, and $595 is the answer. Okay, 7B is a follow-up. What's the future value? Well, you could use 1B if you want. This is the simple interest future value formula, right? But since I already calculated interest rate just now, I'm just gonna add that to my original. 1,000 plus 595 gives me, oops, 1,595. And there we go. Here's 7A and 7B. You guys got that?
Yes.
Okay, sweet. We just have 3 more. Just 3 more to go. Okay, number 8. Based on your budget, you can afford $1,500 per month for mortgage payments. Okay, keyword mortgage. I already know where I'm going to be, 4A or 4B probably. What's the maximum loan you can afford if the interest rate is 4.5% and you want to pay off the mortgage in 30 years, round to the nearest cent? Well, I don't know why I didn't write round to the nearest cent for the previous questions, but just round everything to the nearest cent. Okay, so which one do you guys think? Which formula?
4A.
4A is correct, right? Because I know M this time, I'm trying to figure out the loan amount, the P value. Sweet, let's do it. So P is equal to M, 1 minus 1 N, the negative NT divided by over N. Yep. Okay, let's fill in our numbers now. So we can afford M equal to 1,500. So your interest rate is 0.045. You're gonna pay 30 years, so T is equal to 30. And payments are gonna be monthly, so N is equal to 12. Those are all my variables. Let's just fill them in now. Twelve times 30. Okay, looks like I got $296,041.74. Let's see if that matches. Yup. Here you go.
6.
Yeah, just let me know when you guys done.
Okay, I'm done.
Okay. Yay. Okay, so we have just 2 more. Number 9, make a 5.5% offer on a pickup truck with MSRP of $36,190. Assume the dealer cost is $33,400. Okay. This one. This is one of those ones where there's not really a formula. Like it's kind of you could kind of stretch and say maybe it's the first one, but really it's not really a formula to use, I'd say. You just plug in the percentage. But remember when we make the offer, we just ignore the MSRP, focus on the dealer cost. So at 33,400, we want to make 5%, 5.5 offer. So times 0.055, right? That's the amount of value that you're, this is the value that you're adding on, 5.5%. So you just tack that onto the 32,400. And you end up with 35,237. And that matches here. Other option you have is to, if you want to do one step, 33,400 times parentheses 1 plus the rate that you have. And then you get the answer in one step. But it's the same thing either way. It's very similar to the future value formula and the simple interest formula. If you just to think of T as being 1, then this is what we just did. Okay, is that one okay with you guys? There we go.
Okay, I'm done.
Okay, sweet. Last one then. Find the APR to the nearest 1/10 of a percent. You purchase $2,000 computer with 5% add-on interest for 3 years. Okay. So what do you think we're gonna use here? I think it's pretty obvious. There's only one left, and it's APR.
Yeah. The last.
Yes, last one. So the only one we haven't used so far, right? And it says right here APR, annual percentage rate. So yep, that's the one. Find APR. Okay, so APR. It doesn't give me the approximation. Okay, so anyways, roughly equal, not exactly equal, but this is what we use for estimation of it. 2NR divided by N plus 1. Remember, capital N is the total number of payments, yeah? Okay, so let's see. Capital N is equal to, it says for 3 years. It doesn't say how often, so in that case, we just assume that it's monthly. That means 3 years times 12 times per year is 36. So 36 is capital N. The rate is 0.05% add-on. So those are the two values. 36 times 0.05 times, yeah. This is 36 plus 1. Yeah, so 0.097 as a percent, that's 9.7 to the nearest 10 of a percent. And yep, that matches what I have right there.
0.
Yes.
So 9.
This here. Alrighty, I'm gonna actually just stop the video here because that's the end of the, what you call it? That's the end of the problems.